Bismillahir-Rahmanir-Rahim. In this video, I am going to talk about the introduction of the Six Sigma, but the major focus of today's video would be Six Sigma metrics. I will start about what is the Six Sigma, and then I will try to define Six Sigma in different perspective. But major focus of this video would be the Six Sigma metrics. That is actually how you calculate your sigma level, mean at what level your process is working. That is indicating the quality of your process or the system. So how you can calculate that sigma level, that is our major focus of this video. So let me start with by defining what is the Six Sigma is. So if I talk about statistical angle or a narrow perspective, that is just a sigma mean, that is a standard deviation. That is indicating the variation of the process. But in a broader perspective, if we talk about, because standard deviation is representing the variation, that means how far your data points are lying away from your centered value. That centered value is basically the average value, and how far your data values are lying from your centered value. That is basically called as the standard deviation, or you can say the variation. And that variation is basically the enemy for the customer satisfaction. So what we want that if we want to produce a world-class quality product, that means we need to provide the lesser variation product. That is, we should provide whatever the customer required. We should hit the target value, and then we'll try to produce such product that has lesser and lesser variation. Like over here, I'm showing that the target value is basically representing the mean value. That is, that your process mean is exactly hitting the nominal, that is a target point. So let me take the example of a textile manufacturing. Let's say the length of a shirt, given target, the length of the shirt is given, and our process mean is exactly hitting the that target value. That means we are right now in this diagram, we are assuming that the process mean is hitting the target, and then we are indicating how much you can say defects per million, parts per million we are producing out of the specification limits. So if our process is working on plus minus 3 sigma, that means out of 1 million, how many parts per million we are producing. If our process is working on 6 sigma level, then out of 1 million, how many defects per million we are producing. Remember that in Six Sigma, we always talk about defects rather than defective. So what's the difference between defective and defect? So when we are saying defective, that means we are talking about the entire product. When we are talking about the defect, so that means defective means yes, no, the whole product is defective, the whole product is not defective. While we are talking about the defects, that means one defective product may have multiple defects. So like, for example, if I'm taking the example of a cell phone, so in a cell phone, there might be the screen, the cell phone screen has some defects, maybe the length of the cell phone has some defect, maybe the width of the cell phone has some sort of defects due to our process. So there are multiple defects in a defective product. So in Six Sigma, we always count defects instead of defective. Okay, so remember that in this particular diagram, this is purely a statistical language diagram instead of Six Sigma, you can a quality perspective diagram. Because in statistics, we always assume that the process mean, the average process mean is always hitting the target, and then we are representing how much defects we are producing out of 1 million. But in the language of the quality management, or in the language of Six Sigma, we always report in a longer term perspective Six Sigma instead of a short term, because statistics is always talk about the short term perspective, and they are based on the normal distribution. So that's why they are assuming that the process mean is hitting the target. While in Six Sigma language, because as I told you that it is always talk about the long-term perspective, that means our process mean can shift either right or left. And how much shift can be possible? There is no theoretical background is available, but practically the Motorola said they studied multiple organizations processes and they found that uh, up to 1.5 sigma shift can be possible, or you can say 1.5 sigma is allowed to shift your process mean from your target value, but your process variation must be lesser and lesser. Remember that to control the average value, or you can say to hitting the target is not the problem. You can hit the target, but always the teasing part is the variation in the process. So we have to control the variation. So that's where all the Six Sigma theory is about how we can control the variation. So what are the tools we should use to control those variations? Okay. So I hope you should clear what's the short term and what's the long term sigma level difference. Okay, in this slide, we are going to talk about the four perspective of the Six Sigma definition. Remember that whenever you are considering the Six Sigma project, always start from the Six Sigma philosophy perspective. And what is the Six Sigma philosophy? That you should take your process with respect to y and x perspective, where process is f of x, right? So this is basically your outcome, right? This is your factors, or you can say inputs, right? So these are the basically causes, okay? And these are basically, this is basically the effect. And I would recommend always take it one effect in a one Six Sigma project. Do not consider more than one because it would be hard to handle. But if you can handle it, you can use it. But I would recommend that you should use only single effect, and then you can identify what are the basically causes behind that is due to these causes this particular effect is occurring. So like for example, if I'm saying I'm manufacturing a cell phone manufacturing company, and the fact is that we are unable to produce the proper finishing of the cell phone. So that means the surface of the cell phone is not properly, we are properly able to produce it. So that means, so that is basically the effect. Okay. So that is basically the outcome attached with your output. So remember that what's the difference between output and outcome? The outcome is the characteristics of the output. So the cell phone is basically an output. The outcome is we are unable to provide the proper surface of the cell phone. Now we need to identify what are the causes. So we can list down the multiple causes, multiple factors, maybe due to man, maybe due to machine, maybe due to material, maybe due to other factors. So we should list down all those factors that can be possibly affecting that y. And we are trying to collect the data against those factors, that what's the value of this factor, what's the value of this factor when this particular surface finish occurring on a cell. So that is basically always the Six Sigma starting point, that you should take it as a y is equal to f of x while you're dealing with the Six Sigma project. So in order to analyze this part, we need some tools. So there is a multiple tools are available. That is a qualitative, quantitative tools in a Six Sigma which you can use while dealing with the Six Sigma project. Like we have quality 7 QC tools, we have statistical process tools, we have control chart, we have design of experiment, we have failure mode effect analysis, process capability analysis. So there are set of tools are available in Six Sigma which you can use to analyze this y is equal to f of x relationship. The next part is that how we will manage these tools. So in order to manage these tools, like in order to manage a Six Sigma project, we need a methodology that under what would be the starting point and what would be the next step, then what would be the next step. For that, we need a methodology. And if you want to improve your current process, that is on-ground process, then we can apply the DMAIC methodology, which is define, measure, analyze, improve, and control methodology. So we always start by defining the project which we are taking, like as I have given you the example of the surface finish. So we can define that. So the problem is the surface finish of the of a cell phone, okay, and due to that we are losing this much customers, or you can say you can also define the financial angle, how much loss we are occurring. So if we would able to reduce this variation, so how much saving we can provide. So in a measure phase, what we are doing, we are basically quantifying what at what level we are working right now, mean the current situation of the process. We are trying to quantify the different against different factors, what's the uh, what kind of effect is occurring on your response variable. You can say that is your y, or that is effect. And then in analyzing, basically we are confirming that what we have quantifying that due to these factors this problem can be occur. So we are basically verifying those factors, trying to verify those factors which are actually affecting on your y. Because when we have developed this y is equal to f of x, so we said we can determine multiple axes. Okay, so it could be up to 7 factors. So here in analyzing, what we are doing, from measure to analyze, we are trying to you can say minimize or screening those factors which are actually affecting our y. So in we start from here in order to measure those with respect to those factors, what kind of problem is occurring, and then analyzing, we are trying to screen out, okay, so what factors actually affecting on y. So in improvement phase, what we are doing now, once we have identified, let's say these 3 factors are actually affecting your y. So what should be the level of those factors we should take in our process, that your response variable should be maximum or should be optimum. And then in the end, once we have done the improvement, then we are trying to develop some controls that we should not going downward. We should stay there and try to improve further. So that is basically the methodology which we are using in order to implementing the Six Sigma. The most important part, that is basically the Six Sigma as a matrix. Basically, this is the major focus of this video, like how we will calculate at what level we are currently working and what should be our target. So for that, in order to calculate the sigma level of the process, or you can say the quality level of the process, which we are normally reporting, either our process is working on 2 sigma level or 3 sigma level. So for that, we need to quantify different kinds of metrics. So based on those matrices, we are calculating the sigma levels. So I will talk about this matrix in detail, but before that, let me show you again. That is the on a first slide, as I have shown, that if you are considering the statistical or a short term, then our sigma, Six Sigma would be representing this way. But if you are representing in a long-term sigma perspective, that is 1.5 shift theory, either right or left from the target value. That is, your process mean is not hitting the target. Your process mean is shifted either right or either left side from the mean, and then you're trying to minimize your variation. Then at Six Sigma level, out of 1 million, how many defects you are producing. Remember that, not effective, defects, right? Okay, so always you're considering as a defect angle. So I have explained this slide in a great detail in my previous video, so you can watch the detail on that video about these diagrams. Okay, so in this video, basically we are calculating the sigma level. As I inform you, that sigma level is actually indicating the performance level of your process, or you can say the quality level of your process. So higher the sigma level, higher the performance level of your process. So remember that, don't confuse with sigma level and the simple sigma, which is we call as the variation of the process. So sigma level is basically indicating the quality level, whereas variation is representing how much we are deviating from the average value, which in short we call as simple sigma. So sigma is variation, sigma level is the performance level. So basically, usually what we are writing down 6 sigma. So this is basically, this part is basically called as the level of sigma. Okay, so higher the sigma level, the better the process. Okay, so normally we should want to increase this part, but we want to decrease this part. So if we would able to decrease this part, that is this variation of the process, so this sigma level will automatically increase, right? So remember that while you are dealing with Six Sigma projects, so you always targeting how we can reduce the variation of the process, because if we are able to reduce the variation of the process, our sigma level is automatically start increasing. Okay, so in order to calculate the sigma level, so we need to identify these matrices. So let's discuss these matrices with the example. So let's say we are manufacturing this pair of shoes, okay, and the unit we are considering as a pair. Okay, so one unit is a one pair of shoes, and we found that out of 10 pairs, okay, that is a sample, we found 10 defects. Okay, so in order to calculate the first matrix, that is defect per unit, would be the simple number of defects divided by total number of units. Okay, but the second part is if you are able to want to calculate the defect per opportunity. So how you define the opportunity and how it is different from the unit. So unit is, that is basically the number of samples you have selected, or you can say the number of products you have selected. So right now in this example, the pair is basically your unit. While opportunity is, that is how many number of ways you are identifying, or you can say you are finding the defect. Like right now in this example, I am saying that my opportunity is each part of the pair. Okay, each unit would be representing the number of opportunities. Me, on each part I can find out a defect. So you can increase these number of opportunities, like even you can say the bottom part I would inspect, as well as I will inspect this upper part as well. So as you are start increasing the opportunities, which is the number of way to find the defect in a product, so that means your sigma levels start decreasing. So you have to carefully identify the number of opportunities as well. So in this case, basically, I have identified that the 2 opportunities per pair, okay? And 10 defects and 100 pairs. Using this particular formula, we can find out the defects per opportunity we have calculated. So using defect per opportunity, we can calculate DPMO, that is defect per million opportunity. That is, out of 1 million, how many defects we are producing if we don't improve the process and we start producing this particular way. So simply, if we multiply by DPO with 1 million, so we would able to find out the defects per million. That is, out of 1 million, right now, this process is producing 50,000 defects. Okay, so if you want to calculate the yield, so what is yield? That means percentage of good unit in an output. So that is, we can calculate 1 minus DPO, that is 95% we are producing the good product. So in order to calculate the sigma level based on this information, there is a two-way. Either we can use the Excel formula, that is equal norm inverse, that is 95% is the yield. That means we write down the value of this percentage plus 1.5, that is 1.5 shift theory due to that long-term perspective. Or either you can use DPMO table, that is this one. So in this particular case, if you see that, so my defects is between 44,600 to 54,800, that is 50,000. So my sigma level will be between 3.1 or 3.2. Okay, so if you use Excel sheet, so then you can exactly calculate what's the sigma level. So the current sigma level is 3.145. So this process is working on 3.145 sigma level. So Six Sigma matrix can be used as a benchmark. So right now we are over here and we want to improve this particular process to 4 Sigma level or 5 Sigma level. So how we can reduce? We can reduce by decreasing the number of defects. So what are the causes behind those defects? We should improve those causes, or we should address those causes and try to reduce the number of defects. So let me take another example. So this is from the telecom sector. So we want to calculate the sigma level, and they are giving the information that the telecom has 500 minutes downtime in the year of 2005, right? So that is the information they have given us. So our product over here is the network connectivity. So we want to check the connectivity of our network. Okay, so the CTQ, that is basically the critical quality, is how much our network is uptime. Okay, and the problem is if it is in a downtime perspective, right? So that is our CTQ. So right now we are measuring how many time our network is in a down. The measuring unit we have taken minutes. So our specification, we want that there should be no downtime, and we will consider as an opportunity. Okay, the measurement unit is minute. So that means if our network is down up to 1 minute, then we will consider it as a defect. Okay, so each minute we have considered as a one opportunity. If you are considering as a seconds, then that means if you are measuring in minutes, then your opportunity would be 60 seconds would be your opportunity, mean the number of opportunity per unit. But right now what we are saying if our network is down for 1 minute, then we will consider it as a downtime, or you can say defect in a process or a product. And then total number of defects is 500, because we want to calculate in this entire year. So we know that in a year how many days and how many hours a day and how many minutes per hour. So we calculated the total minutes in a year, and then out of those minutes, how many defects we found? 500 minutes is the downtime. Now we want to calculate the sigma level. So what would be the sigma level? That is basically the defect per unit. We know the formula, that is total downtime 500 divided by total minutes available, which is mean, or you can say the total production time, which is 5,25,600. So this is defect per unit. So DPO would be multiplied by 1. So we will get this one. DPMO, that means out of 1 million production time, there is 951 minutes would be the downtime of the network. So in order to compute the sigma level, either you can use a DPMO table, or either you can use the Excel formula of norm inverse percentage of yield plus 1.5. So right now this process is working on 4.6 sigma level. So let's take another example that is from a manufacturing sector. So in this example, they are saying that we are basically producing 83,934 hard disks, and the manufacturer performed 8 individual checks. So 8 individual checks mean that is there are 8 different quality checks. So that is 8 are basically the number of opportunities. So number of way you are identifying the defect in a product. So based on that, we are rejecting the hard disk. So how many hard disks we have rejected? That means how many defects we have found? That is 3,000. So in order to compute on the sigma level, again, we are using the same formula. So DPU is number of defective or number of rejected unit divided by total. And in order to compute our DPO, so we will multiply by the total unit multiply by 8, because the number of opportunities are 8. Okay, and if we multiply by DPO with 1 million, we will get our DPMO. and the current sigma level of this process is 4.07. So let's take another example of a billing process. Okay, so if you read this particular example over here, they are saying they are basically taking the sample of 250 bills and they found that 60 defects, and they are just checking that bill is correct or not. Okay, so that means the opportunity is only one, right? So in order to do that, so number of defects are 60, number of opportunity, number of unit 250, and number of defects per opportunity per unit is 1. So this process is working on 2.21 sigma level. Okay, let's take another example over here. So basically this is a delivery order process in which we have delivered 500 orders, delivery orders, and we are seeing this process with respect to two angles. One is we will say there is a defect if we delivered late or if we delivered incorrect order. So that means there is a two opportunities. And how many defects? 41 plus 70, that is 58 are defects. Total number of deliveries, that is 500. So using again the same formulas, we can calculate the sigma level of our process. Okay, so let's take another example of this one. So here we have the total number of units, how many total number of units we are. So we have 100, you can say the sites where we are seeing the defects. Okay, and we have categorized the defects into 4 major categories. Okay, and then each category we have find out the number of defects, right? This is basically 5 critical one, 20 this one, and this one. So total number of defects we are finding, that is 300. And the number of units, that means how many sites we have inspected, that is 100 sites we have inspected. And the number of opportunities, how many we have 50 types of defects. So these 50 types of defects we have further categorized into the 4 categories, but actually there are 50 different types of categories in which we are saying if this type of defect is there, we will say there is a defect in this particular site. So we further categorize into 4. So there is actually the number of opportunity to find out the defect are the 50. So using this information, we have calculated the sigma level, that is 3.04 sigma level. So I hope you understand how we can calculate the sigma level of the process. One more thing which I want to add, but before that, I hope remember that whenever you are reporting the sigma level, always add 1.5 because that is basically the Six Sigma idea is because you are assuming that your process mean is not hitting the target, it is deviated from the target value either from the right or left. So whenever you are reporting the sigma level, so it is understood that you have added the shift of 1.5 sigma. One more thing which I want to add is that is basically the yield. That means how you will calculate the yield of the process. So what do you mean? What I mean about the yield, that is basically how we will calculate that what is the percentage of the good unit we are producing. So there is a two way to report the yield. One is the final yield we can report, another is a roll throughput yield. If we are reporting the final yield, which is mostly organization are reporting this final yield, which is not a good idea because in final yield we are only excluding the scrap parts. We consider the first time pass product as well as rework part. Like for example, if there is a 50 parts we have input, mean we want to produce 50 units and we have taken the input of the material for the 50 parts. And this process one is basically when we have input the 50 units, out of those 50 we are produce 4 scrap units and 6 can be corrected with rework. So that means the output of process 1 is 46. So the 46 divided by input, that is the final yield is 92%. The second process input would be 46. Okay, so there is no scrap. 12 can be reworked. So that means that is also incorporated in that one. The output is 46. So that is according to the final yield concept. So the process 2 is 100% right. That means 100% producing the good product, although it incorporated the rework unit. So the third process is the input is 46. Out of that 46, 9 were scrapped and 0 were reworked. So 46 minus 9 would be 37. So 37 divided by 46, that is, you can say 80%. But if, so that means the output is 37. So overall, if we want to report the final yield perspective, the output, that would be 37 divided by 50. So which is, we would say, if we are reporting the final yield, that is basically we are producing 74% good unit, which is not a good way to report the yield. Because when we are seeing the quality angle, so that means produce at a first time and the right way. So that means there should be no incorporation of scrap unit as well as the rework unit. So we should only incorporate those units which are producing that particular process first time good units. So in order to do that, how we can calculate that one, that is, we need to compute out the first pass yield, or a you can say first time yield. So in first, while we are calculating the throughput yield or first pass yield, so we are not incorporating the scrap as well as rework. We are only incorporating those products that are produced first time according to the standard, according to our requirement. So how we can calculate? So I am taking the same example. Okay, so the idea is we have taken the 50 units, so 10 unit would be rejected. That is due to scrap and due to rework. So the output of the first process is 40. So the first pass yield of the process 1 would be 40 divided by 50, which is 80%. And the second process would be, because the output over here would be due to the rework, we are not, that is 46. So that is the output would be 46 minus 12, that is 73.9%. And then input is again the 46, because the rework is added in input. So 46 minus 9, so that is 37 divided by 46. So this is basically 80% is the first pass yield of the process 1, that is without incorporating the scrap and rework. Similarly for process 2, without incorporating the scrap and rework, 73.9% first time how many unit they have produced as per the standard. Similarly for the process. So using the first pass yield results, we would calculate the roll throughput yield. So you should always report the roll throughput yield while you're reporting the yield of the process. That means output of your process. That means first time how many your process is able to produce the product according to the standard. That means we will take the result of the first process, first pass yield, second process first pass yield, third process first pass yield, which we have calculated in the previous slide. So simply multiply that one. So that means this process out of 50, 47.5% product is able to produce first time according to the standard. So if you are reporting final yield, the yield was 74% approximately. But roll throughput yield is actually 47.5%, which is the Six Sigma angle. That is, you should always take those output that is you are producing first time. You are not incorporating the scrap cost. You are not incorporating the rework. I hope you understand. Thank you so much and see you in the next video.